So this is chapter 7, starting with section 7.7. And the first question is asking, if you, using your knowledge of covalent bonding, explain why hydrogen is a diatomic gas. We know that the hydrogen gas is diatomic gas because hydrogen as it is by itself is not stable. Why it's not stable? Because it has only one electron in its outermost shell, and this is not stable. In order to be stable, you have to have two electrons. And it can do this only by one method, since hydrogen is a non-metal. So the only way that non-metal with another non-metal can be stable is by sharing electrons. If it is with a metal, it can make an ionic bond, but since it is with another non-metal, so it can make only sharing by covalent bond. So this another hydrogen atom will contain one hydrogen same way. So both of them will share the electrons between them. The electrons will share in between. If we are drawing it, we'll draw the electrons in between them, or we can draw them with different shapes, X and dot like that. So this represents the electrons. Why it is diatomic? Because in this way it will be stable. Why it will be stable? Because it will feel like it has two electrons the same way like the helium gas. Okay, what in the case of water? In the case of water, if you have water, how does this become stable? The same way for water, we have to know that this oxygen has 6 electrons in its outermost shell. The oxygen has total of 8 electrons. The first shell or the first energy level or the first layer has 2 electrons and the second layer has 6. Remember, we always said that you draw only the electrons in the outermost shell. You don't draw the electrons inside, so you don't draw these 2. The bonding always happens with the electrons in the last layer, and then it reacts with other 2 hydrogen atoms. The hydrogen atom will also share 1 electron. Each one of them will share 1 electron, and the oxygen will share 1 electron with each of them. So now the oxygen feels like it has 8. Originally it has 6 electrons, but it feels like it has 8, same like the noble gas, and the hydrogen feels like it has 2, same like the helium noble gas after it. So this is a covalent. Every one of them tries to share electrons to feel like it has 8 electrons, except the only exception is hydrogen. It tries to be 2, but the rest, all other elements try to have 8 electrons in their outermost shell. ما عدا الهydrogen. Only the hydrogen tries to become 2 like the helium. So the hydrogen reacts with the alkali metals. This section is specifically talking about hydrogen. It reacts with alkali metal to form a white solid, just like halogens do. So if you react the hydrogen with any of the elements from group 1, that's like what? We know that group 1 elements like called alkali metals, Li, Na, potassium, any of them reacts with hydrogen, form a solid. They form a white solid. So these all are white solids. These all are white solids. You need to know the reaction and be able to write it. So the potassium, which is a solid for sure, when it reacts with hydrogen, hydrogen is a gas at room temperature, it will form something called potassium hydride. So KH. And this is a white solid. And also the second one, if it makes a reaction with Br2, it forms something called potassium bromide. So Mr. group 1 element, when they react with hydrogen or halogen or water, there is different reactions that we need to memorize. طب أول واحد احنا قلناه خلاص مع الهيدروجين, it will form something called hydride. So with bromine is the liquid. How did you know, Mr. It is liquid? Because we said the whole periodic table is divided into 3 types of physical states. So do you remember we said that there are 11 elements which are gases and 2 elements which are liquids, and the rest of elements are metals, are solid at room temperature, So if you divided all the periodic table into different physical states, there are 11 which are gases. What are the 11 gases? Do you remember any of them?
لا هم بيدونا البرودكت في الامتحان.
Okay, but they will ask us which of these are gases in the room temperature. So I know that the hydrogen is gas. I know that nitrogen is gas. I know that oxygen is gas. Fluorine is gas. Chlorine is gas. And then I also know the noble gases. So this one, if it is, should not be here. Make it a little bit up here. So I know also that helium is a gas, neon is a gas, and all the noble gases. So argon, the krypton, the xenon, they are all gases. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and there is one more noble gas, xenon, and radon. So all the noble gases, these are 1, 2, 3, 4, 5, 6, and then nitrogen, oxygen, fluorine, and chlorine, and hydrogen. The ones that I drew with the yellow are the ones that are gases at room temperature. But what about the liquids? There are two elements only which are liquids in the periodic table. What are they? Also have to
mercury أعتقد.
Yes, good. So one of them is mercury, and the other one is
و
bromine here, right? So bromine.
bromine.
Okay. The rest, all the other elements in the
solid
will be solid when they are at the, you are speaking
room temperature.
at room temperature. So this is when there is room temperature. Recording. Okay. So if he asked me this one, I should know that it is liquid by myself. How did I know that it is liquid? From here. So liquid, bromine, and mercury. So if I put the physical state, this must be liquid according to my knowledge. Again, the formed compound will be solid again. Now, what if this KH that I have just formed reacted with water? This is what is he asking me, right? What happens when product of each reaction is placed in water? The first reaction product is KH, and the second product is KPR. If you put KH, so it is the second step, KH reacted it with water, which is liquid, and this is solid. It will form KOH and H2. And last time we said that anything that's ionic compound will break down into two ions. So it will be K plus and OH minus. And the hydrogen is gas. This is soluble in water, so it's aqueous and aqueous. I have to memorize the equation as it is with all the physical states has to be memorized. Then what is the second product, KPR? If I put KPR, the solid in water, it will change into K plus and Br minus. That's it. So this is aqueous and this is aqueous. Again, the only way to answer this question is to know, is to memorize it. So in what way hydrogen is different from the halogens? Here, this is formed hydrogen gas. This one does not form hydrogen gas. There is no bubbles. There is no hydrogen gas. So there is a hydrogen gas here. There is no hydrogen gas here. This is the difference between these two reactions. So again, what is the product of potassium with the hydrogen and potassium with the bromine? And the product is again added to water. What is the result in every one of them has to be memorized. Okay. So write equation for the following reaction in each case from A to G. State what of the bonds are formed and what type of compound results. So what he is reacting into what? He is taking all the elements in the period number 3 and reacting them. So now he is focusing on the third row elements. Where is the third row elements? So this is a periodic table and this is the third row. Means period number 3. What's period number 3? This is period number 1, 2, and 3. So he is specifically focusing on these elements from the sodium until the argon. This is the ones that he is focusing on and will react. So he will react them with what? Let's see. The first reaction is reaction between the sodium with sulfur. The second one, he reacts the magnesium with chlorine. The third one, aluminum with oxygen. And the fourth is reaction between silicon and sulfur and argon. Mr. Why he is picking these questions exactly? Why he is picking here? Why he is reacting the sodium with sulfur, the magnesium with chlorine, the aluminum with oxygen? Actually, we are required to know more reactions than that, but the ones that he has brought in the question is only a few chosen ones. So you don't need to know sodium with sulfur only, all the elements with sulfur, all the elements with chlorine, all the elements with oxygen, all the elements what in this period. So we need to know not only magnesium with chlorine, sodium with chlorine also, aluminum with chlorine, silicon with chlorine. And where can I find these reactions? Because these reactions has to be memorized. So Just see the table that has all these reactions, and we need to memorize one. Just show you the table 1 second. So this one table contains all the reactions that we need to know, and we need to memorize them all. So the ones that are in the questions are just some of them only picked. So let's just try to make the table a little bit smaller, because it's a big table and has to be all memorized. Let's see the table. This is the one. And again, I'm saying this is the reactions of elements of group of period 3. So this is the period 3. And this is the reactions required. So this means that he has just picked some of these. Let's see what are the elements. This is the sodium, magnesium, aluminum, silicon, phosphorus. So again, as we said, he is talking about reactions of period 3 elements. These ones, can you see? So this is the one he asked it for. So Na, this is Na, and then magnesium, and then aluminum here, and then silicon, and then phosphorus, and then sulfur, and chlorine, and argon. So all of them, he has reacted them with the same 3 elements. So he first saw what happens when these elements reacts with hydrogen, what happens when you react them with chlorine, and what happens when you react them with oxygen. That's why the questions again are here, are just examples of all this. So I have to memorize this reaction 100%. I have to memorize it. It's a little bit easy, some of them too, if you just categorize it, but at the end you have to memorize it. Like how? So let's try to make it a little bit easier. All of them, when they react with hydrogen, they will form something hydride. So the Na, when the Na reacts with the hydrogen, it forms NaH. The second one reacts with hydrogen, it forms MgH2. What is the difference? Why this become 2? Because Na is in group 1. So hydrogen is -1. So +1 and -1, they are cancelled out. There is no numbers showing here. There is no 2 or nothing. So this magnesium is in group 2. So it is +2. And hydrogen is -1. So again, we said if the numbers are similar, just cancel them out. If they are not similar, if they are different, just switch the numbers. So I brought the 1 become here, and the 2 became here. So it become MgH2. So here, that's why it's NaH, but here it's MgH2. What about aluminum? Aluminum is in group 3, so it's +3. So what do we do with +3 and -1? Again, switch them. So it became AlH3. Let's try to do it again. This is NaH. N is in group 1, and this is in -1. Again, this is Mg and H. This is +2 and -1. Al and H, this is +3 and -1. Here the numbers are similar, so just cancel them out. It becomes NaH. Here is this difference, so switch them. Put the 1 here and put the 2 here. So it becomes Mg1, we don't write it, and H2. Again, switch the numbers. 1 come here and 3 comes here. So the 1 goes here and the 3 goes here. Switch them. So it becomes Al, under it 1, don't write 1, and then H3. It's like that. The silicon, again, silicon is in 4. So silicon, let's try silicon. Silicon is in +4, and hydrogen is -1. So again, switch the numbers. What will be the product? Put the 1 here and 4 here. So 1 becomes here and 4 here. So the compound is SiH4. The fifth one, the table becomes a little bit different here, because here the phosphorus is -3. So why the phosphorus become -3? Because it's in the non-metals, and we said non-metals, they don't gain, they lose. So instead of becoming +3, it becomes -3. So what is the nitrogen? Nitrogen is -3, and hydrogen is +3. So it's like that. It's +1, I'm sorry. So it's +1. So switch the numbers again, it becomes NH3. So it becomes the ammonia. This is not the nitrogen, the phosphorus first. I'm sorry, this is the phosphorus. We need to make the phosphorus. Phosphorus is the same thing. Is -3, and hydrogen is +1, so it becomes BH3 when you reverse the numbers. Where did you get these numbers from? +1, +2, +3, +4? It's as we agreed before. So if you have anything, any element in group 1, it will become +1. Any element in group 2, it will become +2. Any element in group 3, so it becomes +3. Any element in group 5, it becomes -3. Group 6, -2. group 7 minus 1. This, you have to memorize this very well. So this phosphorus is in group 5, so it becomes minus 3. So it becomes pH 3. What about the next one? Next one is 6. This one is a little bit confusing because we have just to memorize it as it is. This is an exception that we have to memorize it as it is. It becomes H2S. So this one you have to memorize as it is. H plus S, it gives you H2S. And this equations also has to be memorized. Mister, that's too much. Yes, it is too much. It's the most difficult part in the chapter, and it's very nauseating, but has to be memorized. And then the Cl with the H, it forms HCl. The last thing is argon is very easy because this one part of the table is already very easy to know because we know argon is a noble gas and noble gas does not react with anything. So that's, for the sake of God, that's very easy. I don't need to do anything here because this is no reaction with nothing. It reacts with nothing. It's all no reaction. So it's repeated, no reaction, no reaction, no reaction in any of them. So once you are done with the hydrogen, you will go for the chlorine. What does every one of these elements in the period 3, sodium, magnesium, aluminum, silicon, does when it reacts with the Cl? So it's a little bit similar here to the hydrogen at the beginning. So what happens with the Cl? Again, plus 1, minus 1, so cancels, become NaCl. You have to memorize that this is ionic, and this is ionic, 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 and ionic, and ionic, and ionic, and this one is a little bit exception, so it is covalent. So the aluminum with chlorine is covalent, while the rest was ionic. So if you ask it about anything in the Na and Mg and Al, they always make an ionic. Why they always make an ionic? Because they are metals. They are in the metal side, on the left side, and we said they are metals, make ionic. The only exception is the aluminum chloride. This is also has to be memorized because there are two products here. So plus 1 and minus 1 give you cancelled out. Plus 2 and minus 1 switch, so becomes 1 and 2. Plus 3 and minus 1 switch again becomes 1 and 3. But here there is one extra product that has to be memorized. This product is coming when this one is doubled. So you see AlCl3 is doubled, it becomes Al2Cl6. So one AlCl3 joins one more AlCl3, is dimerized and becomes Al2Cl6. Has to be memorized, this one. And then this is the compound. In case of oxides, we'll just finish the chlorides first. In the case of Si, it becomes SiCl4. P, it has two products. S, it has two products. What is this products, mister? The reaction of sulfur with chlorine. Chlorine with chlorine. Chlorine with chlorine forms Cl2. So that one is easy. And this also has to be memorized as molecular. You will be asked in anything in this table. So it takes you a lot of effort to memorize this table, but it will pay out in the questions of the equation. So if you see a question like that, he asked it silicon with oxygen, sulfur with hydrogen, magnesium with chlorine. You can just note if you have memorized the table very well. Again, in case of oxygen, Na and O. So let's see how Na reacts with O. This is plus 1 and minus 2. So shift the numbers, it becomes 2 and 1. Plus 2 and minus 2, they cancel out, no numbers here. Plus 3 and minus 2, shift the numbers. So the 2 comes to the left and the 3 goes to the right. SiO2, you have to memorize it as it is because you will not know why it came like that. Also, in the case of phosphorus, there is always two compounds, so memorize both of them. In case of S with the oxygen, it forms either SO2 or SO3. And in case of chlorine with oxygen, it forms either this one or this one. The things that we have marked with the red are all non-related, and they are not easy to understand by ourselves and has to be memorized without any reason. This one is network solid, and this is giant solid. So the more you memorize from the table, the more it will help you in the questions. Let's see one of the questions, how we use the table in it. For example, when he asked us what is the reaction between sodium with sulfur, so it formed something NaS, magnesium with sulfur, it's all written here, magnesium chloride, and this ionic and compound. How did you know that this is ionic or compound? Because we have memorized that when magnesium reacts with chlorine, it forms ionic. If we did not memorize it here, if you did not memorize it here, you will not know how to put it here. Aluminum with oxygen, also in the table we have memorized that aluminum with oxygen forms aluminum oxide. It's ionic. If you did not memorize it, you will not know it's ionic. Okay, and then The question between argon and hydrogen is no reaction, of course. H2 and H2 and S, this one was in the table here. So it was in the table here in the case of H2 and S. And the last question also was that one. Sulfur with hydrogen, so silicon with chlorine, this is silicon chloride, and this also forms the memorization. Very, very difficult table. I will not say that it is an easy table. I will not say that it is easy to memorize, but if the question came and you don't memorize it, then there is no way. I will not know that this is network solid SiO2 unless I memorize it. So it will take a lot of time from me, but at the end, when I am asked in any of the questions, I will be able to write the equation very easy. Sadly, there is no other way than memorizing, okay? Use the trend in reactivity of halogens to predict the spontaneity of each of the following reactions under normal conditions. Mister, this one we talked about last time when we said I have two elements trying to fight with each other. The one which is more reactive will be able to kick the one that's less reactive from its compound. So I have two elements. One is more reactive and one is less reactive. Let's try to remember the elements from group 7 together. The first one was fluorine, and then chlorine. You don't write Cl2 in the table. Then bromine, then iodine. The last one is astatine. Don't say too much. So this is group 7. What happens to the reactivity when you go down? When you go down the group, what happens to the reactivity? The reactivity decreases as you go down the group. So the reactivity decreases down the group, and the more reactive can kick the less reactive. So if you compare any of them together, let's see in the fight what happens. What happens in F reacts with Cl, the Cl with the Pr, so any two together, the I with the F, the Cl with the I, like that. See which one wins over the other. The F is higher than Cl, so it is stronger, so it can kick it out. The Cl and the Pr, Cl is stronger than the Pr. What about the iodine and fluorine? Oh, the iodine is weaker than the fluorine, is less reactive. Why? Because the activity decreases down. Fluorine is more reactive than iodine. So let's see which one is more reactive than the other one, fluorine. And what happens in the reaction? Well, let's see the first one. Then there are always one sitting in the car in its compound and one trying to kick it out. So again, which one kicks which from its compound? Let's try to make it in the form of a question. So what displaces? Instead of kicking out, in the exam will say displaces. So takes its place. Displaces the what element from its compound. Which one displaces which one? The more reactive displaces the less reactive, or the less reactive displaces the more reactive? The more reactive.
The more displaces the less reactive element from its compound.
Exactly, the less reactive element from its compound. So usually the one which is not inside the compound displaces the one which is inside. So let's imagine the compound as a car. So the compound is usually a car. It contains what? It contains the less reactive compound. So this is iodine sitting with the sodium. What is the sodium in the reaction? It's just sitting here. It doesn't do. The fight is usually between the elements of which group? Group 7. So the sodium does not interfere with the fight. It's called what? It's just watching. It's like in the match watching, so just spectating. It's called a spectator ions. What does it mean, spectator ions? It doesn't care who comes here, iodide or chlorine. So the fight is between who? The group 7 elements. Now let's try to see who is trying to come. The one that's trying to come is, for example, you said chlorine and iodine. One second, just take a break 1 minute. Okay, so again, the one that's outside trying to go inside. So it's trying to remove the iodide from outside. Let's see the fight, how it will go. Mister, you said the more reactive kicks the less reactive from its car. So the fight is between the chlorine and the iodine. Okay, take care, it will be written as Cl2 again. So, before writing it as Cl2, let's see the fight. The chlorine and iodine, which one is more reactive? Chlorine and iodine. Let's put that one here beside us so we don't forget. So this one plus this one. Which one is stronger, the chlorine or the iodine? Chlorine is higher, so it's more reactive.
Chlorine is stronger.
So it is able to do this reaction. It is able to do this reaction. If you try to reverse it, it will not be able to do it. So if you tried, if the chlorine was the one sitting in the car with the sodium and the iodine tries to kick it out, it will not be able to do it. Why? Because iodine is weaker. It's less reactive. So what will happen here? You will say it's a no reaction. What does it mean, no reaction? It means non-spontaneous. He said, is it spontaneous or non-spontaneous? Non-spontaneous means it will not happen by itself. Non-spontaneous means no reaction. Why is non-spontaneous? Because it's weaker, it's less reactive. So it will never be able to do it. While the opposite can happen. So I will say it's called spontaneous. So let's say it's green color. So we know it happens. Spontaneous reaction. It happened. What will happen exactly? It will sit instead of it. It will take its place. So it will take its place. Let's see how it happens. So what will be the product? Now what happens is the car, the same car, the sodium is still sitting in it. As we said, the sodium does not care who is inside. But who came instead of the iodine? The chlorine came inside. And who is kicked out? Who will be kicked out now? Which one is kicked out? The iodine is kicked out.
The iodine.
So the iodine is the one which is kicked out from the car. Why? Because chlorine is more active.
Chlorine is stronger.
Yes. So we said that the more reactive displaces the less reactive from, I don't know where we wrote it, from its compound, which is, we symbolize it as the car here. The only thing that might confuse you is the numbers. Sometimes I see that there is 2 here and there is no 2 here. So let's just talk about the halogens. Halogens are group 7. This is all called halogens, group 7 elements. This chlorine, bromine, iodine, they are very reactive. Very active means they cannot sit by themselves. They have always to be combined. It's like some of your friends are very reactive. They cannot sit. You cannot find them sitting by themselves. They are very extrovert. So the group 7 is very extrovert. They are never by themselves. So how come? Here it's sitting with the sodium. So it doesn't need to be 2. I don't write 2. Why you don't write 2, mister? Because it cannot be. This is +1 and this is -1. So just cancel the numbers. Why you didn't write 2, mister? Because it's already with someone. It's already with the sodium. But when it is alone here, it cannot be Cl. It has to be Cl what?
Cl minus. Cl2.
Why? Because it cannot be alone. Again, the iodide here is not 2 because it's with the sodium. But when it is kicked out, what happens? It will become I2. Why? Because it cannot be alone.
Cannot be alone.
Why it's not 2 here? Because it
already has Na.
It already has Na. Very good. So let's try to write the equation in the same way. So let's try to change this one into an equation and write it down. This is Cl2 reacts with NaI. What is the product? Is it spontaneous or non-spontaneous? Can it happen or it will not happen? It will happen. Why? Because Cl is more reactive than I, so it can kick it out. So what will be the product? The Na is just sitting here, and so let's write it in the same place. Na is just with the same colors even. So Na is just sitting here, Na, and then Cl. You don't need to write it as Cl2 anymore. And then what is kicked out? The I. The I should be now I2. But wait, this is not balanced now. Now I have 2 I's, and here I have 1 I. So what I should put to balance it? Should I put a 2 here? No, mister, you never balance with the compound. You always balance by changing what's here, right? So I write 2 here. Why did you write 2 here? Why you didn't write 2 here? If you write 2 here, you are changing the compound. You always balance by changing the number before the compound, not the subscript, by changing the coefficient. So 2. What about the chlorine now? Chlorine is 1 here and here 2. So it will become 2. Now the sodium is 2 and the chlorine 2 and iodine is 2. It's balanced. So don't balance before writing the equation. First write the equation and then balance it. Now we'll see the question. The question tried to give us some of the examples so that we know it happens or it doesn't happen. Let's see the same. Let's try to do the same way. I will just imagine it in my own way for the first one only. This is my car and the potassium. What, Mister, it's not sodium. I don't care. It is somebody else, another spectator, sitting with the potassium and the chlorine comes. Is the chlorine able to do it? Let's look at the periodic table. FCl higher than PR, higher than I. Will the chlorine be able to make the reaction or it's not going to happen? Don't try to do the reverse because some of the students try to make the iodine kick the chlorine. Kick it from where? It's already outside. So the opposite that wants to happen, not this one. So the chlorine trying to kick the iodide. Is it going to be able to do it or no? Yes, chlorine is higher. So what will be the product? The potassium is just sitting here and the chloride came instead of the iodide. Now it doesn't need to be Cl2. It is already 1. And what is kicked out? The iodide. It becomes
I2.
So it becomes I2. Let's try to do the next one. That's I2 plus Kf, but we'll do it ourselves. So I2 plus Kf. So this one was spontaneous, by the way. It happened. Spontaneous means it happened. So I2 plus Kf. What happens here? The I2 tries to kick the F outside. Is it going to be able to do it? Will the I2 be able to kick the F?
No.
No, because I is less reactive than fluorine, so it cannot do it. So we are going to say that this is a non-spontaneous. If he asked us if it's spontaneous or non-spontaneous, we'll say it is non-spontaneous, so the reaction does not happen. Mister, he has made the reaction here. The F2 is kicked out. No, he said here that it is non-spontaneous. It's not going to happen. So bromine plus KCl. So bromine plus KCl. So bromine plus KCl, what happened? Bromine plus KCl. The PR is more reactive or the Cl? Again, the PR is less reactive than the Cl. So again, it's not going to happen. Non-spontaneous reaction again. Let's try to do one ourselves, which is spontaneous, and see what is the product. So we can write it down. So first is the reaction between F2 and KCl. Let's see, does this work or no? So F2 will try to kick the Cl out, right? Yes.
Right.
It can do it. It can do it. Why? Because F is more active. So what will be the product?
Spontaneous.
Yeah, spontaneous. So what will be the product? What will happen?
It's gonna be Cl2.
Cl2, Cl2. And then what is the K sitting with K?
K2.
K1?
K minus.
Okay, and then what's removed? Cl is removed. What's sitting instead of it?
F.
Yes, so it will be F. Do I need to write F2 or just
No.
F? Okay,
just F because it already came with it.
Yes, +1 and -1, so cancel out. There is no numbers K. But still, it's not balanced, so I need to balance it. So here I have F2, but here one F. So what should I write here in order to be balanced? Where is the change that I should do? F2 and KF. Where I should balance?
two ورا ال K و 2 ورا ال KCl.
2 should put 2 here and 2
there.
So it is 2 and 2. Now everything is balanced and correct. The last thing is to put the physical state. Mr. F2, I remember that when we talked about the physical state, this is where it will help. We said that the F2 is one of the gases. Is one of the gases, right? So F2 will be a gas. So I have to write here F2 gas. How did you know? We said this is a gas. KCl is a solid. How did you know? We said that any put here any reaction here. This is where we said reaction between potassium and hydrogen or potassium bromine, it makes solid. So this one makes solid. This is a solid. And Cl2 is produced. This is a gas also. And this is a solid. So if you have I2, it will be liquid. If you have Br2, sorry, I2 is solid, and this is Br2 is liquid, because we said Br2 and Hg are liquids, right? Okay, so the next question is, identify the substance that colors a flame red. What colors a flame red? Which one of the three we took last time was making a red with the flame test? The lithium we said is color red, right? And the sodium
lithium.
was
Yellow.
And which one was lilac? The potassium was lilac, right? So the one that colors a flame red is the lithium. So which one formed a cream color precipitate with the silver nitrate?
Bromine.
Okay, but take care, because if you wrote bromine and not bromide, it will be considered as wrong. Why, mister? Because the bromine itself does not form a color, does not react with silver nitrate. It has to be bromide. So bromide or Br minus is the one that makes the reaction. The blue crystals that become a white powder when heated gently. What is that, mister? I never heard about that. This is something called copper sulfate crystals. This is a substance called copper sulfate. Copper sulfate, how does it look like? It looks like it has blue color like that. So it has blue colors. Crystals. It has water inside it. So it has water. It's called hydrated copper sulfate. It has water inside. If you heat it, what happens to the water? If you heat it, the water will be removed. So it will become called anhydrous. So instead of the copper sulfate that is hydrated, it will become called anhydrous copper sulfate. And then strangely, its color will be now white color crystals. So it will be a white powder or white color crystal. So what happens if you put water back again? Then it will change from anhydrous again into hydrated. Into hydrated one, exactly. So it will become blue color again. So you keep doing like that. You remove the water by heating, it becomes anhydrous and white. You add the water, it becomes blue again. So the question asks, what are the blue crystals that become white when heated gently? This is the copper sulfate. So this is the copper sulfate or the hydrated copper 2 sulfate. You can memorize it as CuSO4 or copper 2 sulfate. طب what is the dark gray shiny element that sublimes into purple fumes؟ يعني ايه يا مستر؟ ايه الحاجة اللي انا في المعمل لو دخلت عليها هلاقيها solid ولكنه السوليد دوت لونه purple او blue او dark gray crystals، ولو اتسخنت شوية it will be changed into purple fumes. يعني ايه sublimes؟ يعني changes from what to what؟ from the solid to the gas directly. ايه ده يا مستر؟ مش المفروض الحاجه اللي بيحصل لها heating بتتحول من solid الى liquid الاول؟ لا، الايودين دايما has a property that it sublimes. يعني ايه sublimes؟ يعني فجاه كده الاقيه يتحول من السوليد الى الجاز من غير ما الاقي له liquid. غير الووتر مثلا، صح؟ الووتر ايه اللي بيحصل للميه الاول؟ هل الووتر بتتحول من الايس للووتر فيبر على طول؟ لا، الووتر لازم تتحول الى ايه؟ الى liquid الاول، وبعدين تسيح الاول to be melted first, change into water liquid and then. لكن البرومين اهو ده البرومين, it looks like that. So it is a little bit dark gray. فجأة ما ببص ما لقيتش فيه water، ما فيش liquid، اتحول الى fumes. So this is fumes او vapors. ايه السبستانس ديت؟ اسمها الايودين. So why iodine does like that? It's a property in it. مش انا اللي اقدر اعملها. طب انا ممكن اعمل sublimation لاي substance ثانيه على مزاجي؟ لا. This is a property in iodine. So the iodine has a property that it sublimes at a little bit high temperature. امال هو في الاول بيكون ايه يا مستر؟ solid. عرفت منين يا مستر ان هو solid؟ لان احنا ما جبناش سيرته في الحاجات الليكويد ولا الجاز. Do you remember? We said here fluorine, chlorine. Fluorine and chlorine هما الاثنين كانوا ايه؟ They were both gases. So this one is gas and this one is gas, and bromine was liquid. What about the iodine? We did not mention iodine. So this means that it was what? Solid. So that's the answer for it. Iodine is a solid, and we said it is a little bit dark gray, shiny element in the form of a solid that sublimes into what fumes? Purple fumes. The solution turns brownish when Clorox and acid are added to it. What is that? We mentioned this last time. Which one turns brownish and which one turns black? Yeah, Mr. Clorox and acid. Mr. We said that when you add bromine and iodine to water, they are confusing because both of them become brownish. Both of them become brownish. عشان كده دورنا. That's why we looked for something instead of water. We said we'll use something called CCl4. How do you make the CCl4? By adding Clorox to acid. So when you add Clorox to acid, you get the CCl4. Now there was a difference. That one looked brownish, and that one formed a black color. So why did you use CCl4? To differentiate between bromine and iodine. الاثنين دول, if we put them in water, they become brownish. They become brownish. So I cannot differentiate between them. So instead of using water, use what? Carbon tetrachloride. It's called CCl4. So he asked again, what is the solution that its solution turns brownish when Clorox and acid? Is it bromine or iodine? It's bromine or iodine, mister? It's bromine. So the answer is bromine. So I have just to memorize this one because they will come in the exam as it is like that. So it is bromine. Oh, sorry, this is the one before. So it's bromine. And again, Mr., what's the least dense unreactive gas that I should know about? The hydrogen gas. What is the least dense reactive? Oh, this is nitrogen, sorry. Helium. This is helium. And this is hydrogen. The least dense alkali metal is lithium. This is all by memorizing. Is a gaseous diatomic element that constitutes most of the air is nitrogen. So this all has to be very well memorized. Like complete and balance the following equations. If no reaction takes place, write no reaction. Can we do this, mister? Yes, we can do most of them by the information that we know. So Ki and AgNO3. Mister, this is the reaction that formed a yellow precipitate. Last time you told me that if you put iodide with silver nitrate, it forms white or yellow or creamy. Does it form white or yellow or creamy color?
And yellow.
Yellow color. So the precipitate is called silver iodide. Then bromine plus KCl. Does bromine react with KCl? No. Why? Because bromine is less reactive than Cl. Bromine is less reactive than Cl. طب H2 plus Cl2, memorize, it forms HCl. NaF plus AgNO3, no reaction. Cl2 plus Li. Mister, what do I do here? Memorize. Mister, it looks easy for you because you just say like that. But for us, it's difficult. Yes, I know it's difficult, but still you need to do it. And there is no other way. You have to memorize all reaction. I know it's difficult, but you have to do it. Memorize all these equations. Is there a way that makes them a little bit easier? Yes. For the reactions that does not happen is the first, this one, no reaction. And we know the reason. And this one, F, does not react, no reaction. Why, Mister, this is no reaction? Because that has F. So F plus AgNO3, no reaction. امال مين اللي كان ليهم reaction يا مستر؟ Cl has a reaction, LPR reaction and iodide reaction. What was the product in every one? The first one formed a white precipitate. The second one formed a creamy precipitate. The third one formed a yellow precipitate. So first one formed what? Chloride with silver nitrate, white precipitate. The last one formed a yellow precipitate. What is the name of the precipitate, mister? It's called AgI. It's called AgI. The last one is called, this one is called AgCl. And here is creamy. That's AgBr. What about this one? It does not react. So fluoride, the only one from the group 7 that does not react. So no reaction. Li plus Cl forms LiCl and then balance it. So LiCl and then balance it. H2 مع K, that's HK and then balance. NaH مع H2O, NaOH plus H2. I'm very sorry. It's difficult. I know it's difficult, but you have to memorize. HCl plus NaOH forms NaCl plus water. This is a neutralization reaction. So identify the type of bond that exists between atoms of the following groups. Mister, how do I know this? How do I answer this question? So how do I answer this question? That is an easy one. I don't need to memorize this one. If you have an element from the left side of the periodic table and an element from the right side, what kind of bond they form? You know that one, mister. You take something from the left, metal, and you take something from the right, non-metal. What is the type of bonding? Is it covalent or ionic? It's ionic chemistry. So let's see. He took something group 1 and group 7. So one from here and one from here. Then it is ionic. But if you took something from the non-metals with non-metals, what is the answer? Non-metal and non-metal. What is the answer? This time it's covalent. So again, let's say, yes. So non-metal plus non-metal, it is covalent, but metal plus non-metal is ionic. So let's see the second one. He said group 6 and 7. So both of them are what? Non-metals. Both of them from the right side. So they are covalent. Top 2 and 7, 2 and 6, 2 and 6. So one from here and one from here. So ionic. Both of them are in 7. Both of them non-metals. So covalent. Both of them are in 6. So both of them are covalent. So both of them are non-metals. Again, if one metal and one non-metal, it's ionic. Like which example? That one and that one. Let's see. So A, this is group 1 and group 6. One is metals. عرفت منين, Mr. How did you know it's metals? Here, I can tell you again. So which one is metals and which one is non-metals? Metals are group 1 and group 2 and group 3. The rest are all what? Non-metals. 4, 5, 6, 7, 8 are all non-metals. Group 1, 2, and 3 are all metals. So he took 1 and 6. 1 and 6. So here left and right, so it is ionic. Then 6 and 7, so right and right, both non-metals. So both are non-metals, so it is covalent. 2 and 6. So 2 is from the left and 6 from the right. So it is ionic. Both of them from 7, both of them from the right side, it is both non-metal, so it is covalent. Both of them are from 6. If both of them are from 6, then both of them are from 6, both of them non-metal, so it is covalent. So this one should be easy. Which of the following forms an ionic? It is the same thing, mister. It is the same thing. But this time he doesn't tell me the group number. I should know the group number by myself. Group number. He doesn't tell me it is from 1 or 2 or 3. How do I know the group number? I have a secret key. It tells me that the group number is the same as number of electrons. In which shell? Innermost or outermost? Outermost. I don't understand. Let's see. X has 11 electrons, right? How do you know? Atomic number is 11, so number of electrons is 11.
11.
How can you distribute the 11? The first shell carries 2. Second one
carries 9. 8, sorry.
And then
لا 9 9.
No, the second one maximum 8. The second one
صح.
maximum 8. So what is remaining from 2 and 8? There is 10.
1.
So remaining is 1. So how many electrons in the outermost shell?
1.
So what is the group number of X? X is in which group? Group 1. What about Y? Y is 2 and then 8 and then
4.
4. So it is in group
4.
Z.
Group 6.
8 and 6. So it is in group 6. 7, 2 and
4.
2 and 4 7 or 2 and 4 6?
صح 2 and 5.
2 and 5. So it is group 5. Okay, so group 1 is metal or non-metal? Group 1. This is a what?
Group 1 is metal.
Metal. Group 4 and 6 and 5, all of them are
All of them are metal. لا ثانية.
4 and
Non-metal.
all of them are non-metal. So this is non-metal, this is non-metal, this is non-metal. Okay, X and W. X is metal and W is
Non-metal.
non-metal. So it is ionic. Which one is ionic?
X and W.
This is X. Okay, X and Z.
X and Z.
Metal and
Ionic.
ionic. Okay, Y and Z.
Covalent.
Mr. Y and Z is covalent. Y and Z is covalent. Why did he write? Mr. X.
Non-metal. Non-metal.
Okay. He said true A and B. Oh, this one is non-metal, so it is covalent, huh? Y and Z. Type Y and W, 4 and 5. Both of them non-metal, so it is still
Covalent.
covalent. Top Z and W,
Covalent.
covalent. So only the first two are
Covalent.
are,
Ionic, sorry.
are ionic. Very good. So diagram below shows the allocation of 4 elements X, Y, W, and Z in the periodic table. X combines with W to form an ionic compound X2W. Mister, what does this mean? Let's see it. Let's try to do it slowly. So X comes with W. X is from metals and W is from non-metals. Which group is X? Group number 1. And which group is W? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So group number 6.
But Y is group 4.
And Y is group 4. And Z is group
2.
2. Okay, X comes with W. X and W. Mister, you told me that anything from group 1 takes a number of what? Group 1 loses 1 electron. It becomes plus 1. Group 2 becomes plus 2. Group 3 becomes plus 3. Group 4, we don't mention it. 5 and 6 and 7. This one becomes negative
Negative 3, negative
2,
2, and negative 1.
negative 1. Okay, let's keep this one with us here. We will need it here.
هو الحصة تخلص امتى يا مستر؟
We are almost done. This is the last question.
Okay.
So this is plus 1, plus 2, plus 3, minus 3, minus 2, minus 1. Okay, I have X. X in group what? 1. So what is the number with group 1? Plus 1. So I'll
Plus 1.
here. What about W? Group 6. So it will become
Minus 2. Minus 1 total.
minus 2. Then what do I do with the numbers?
We add them.
No. If the numbers are the same, I cancel them out. If they are different, I switch them.
Oh, okay.
So X and W. X takes the 2 and W takes
The 1.
the 1. So the compound becomes, I don't write the 1, it becomes X2W. So it's true. Type Z has 2 electrons in its outermost shell. Is this correct?
Yes.
Yes, because in group 2, so it's true. Y compounds with Y to form what? Let's see W and Y. W and
Form
Y.
form a covalent bond. Correct.
Form a covalent bond. This is Y. Y is group 4. And W becomes
The W is group 6.
group 6. So that it forms
Non-metal covalent.
non-metal covalent. Okay, but how does it form Y and W? This is
Y.
This is why it will share like that. It will share with 2 electrons. So it will form like that. This is 1W and 1W. The Y has 4 electrons in group 4, so it will share 2 here and 2 here. And the W is in group 6. It will need to share 2 electrons out of the 6. It has 1, 2, 3, 4, 5, 6. And the other one, 1, 2, 3, 4, 5, 6. So originally it has 6 yellow electrons, but it will feel like it has 1, 2, 3, 4, 5, 6, 7, 8. So it feel like it has 8. And the other one, it has originally 6 yellow electrons, but it will feel like it has 1, 2, 3, 4, 5, 6, 7, 8. The Y has 4 electrons, the blue ones, 1, 2, 3, 4, but it will feel like it has 8. So 1, 2, 3, 4, 5, 6, 7, 8. So now it become Y and 2 W's, so it become YW2. I know this is a little bit difficult. Z has more metallic character than X. Is that correct? This is also a difficult question, but it is true. W is a group 7. You should not take this one now. It's a little bit more advanced, but he has given this question, so we have to answer it. It's true, yes, it has more metallic character. W is a group.
Okay.
W is a group 6 element in the periodic table. Yes, this is group 6.
Yes, correct.
So all of them are true, and that was our last question. Just close the recording.